Hello everyone, my name is Tong Tiang Yong and my matrix number is CE1901337. First and foremost, thank you for my lecturer Dr. Arifuddin bin Joret give me this opportunity to present about the title Finite Impulse Response Filter for Real-Time Filtering Application, which are related to the course BEJ30603 Digital Signal Processing. We are Group 3 and from Section 2 student.
Hi, my name is Nishley, matrix number CE1900005. So I will explain about the introductions. In this DSP project, we have picked up FIR filter for real-time filtering applications by using MATLAB to show the output of our finding. As known, digital processing DSP is concerned with representing discrete time signal by a sequence of numbers of symbols, and the processing of this signal, it has wide range of applications. So by picking this FIR filter project as our title, we could show whether the way of the FIR filter propagates and transmits in our digital electronic system. In this project report, we will include introduction, literature review, problem statement, objective methodology, result analysis, and conclusion to present the whole idea of our finding and the result. So my friends, that will present later. Overall, from the information we gather and the output shown in MATLAB, we could explain better that in signal processing, a finite impulse response filter is a filter whose impulse response is of finite directions because it settles to zero in finite time. That's all for me. Thank you.
Hello, my name is Aina Devenji Zulkifli. My matrix number is DE180066. So I will be present about the literature review. So the most common kind of software filter is the FRI filter, which may be discrete time, continuous time, analog or digital. It is possible to create a FIR filter in the frequency domain of the time domain by determining the coefficient and filter order that can fit certain parameters. When the input signal and the time reverse impulse response are cross-correlated, a FIR filter convolution is created. The impulse response of the match filter is built by sampling the known pulse form and utilize those samples in reverse order as the filter coefficient. The filter output is generated using a multiplier and adder and a sequence of delays. Next, the problem statements. Many digital signal processor DSPs make use of finite impulse response, which is FIR filter. A fundamental issue in digital signal processing is the construction of digital FIR filter. Any real-time filtering application may benefit greatly from a FIR filter with numerous operating capabilities. As a result, this area has gotten a lot of attention during the last 30 years. In DSP application, it is commonly employed. So the signal preconditioning, video convolution function, and communication are only a few examples of this function. So for me, thank you.
Assalamualaikum and hi, my name is Nukada Daniel. So today I will explain about the objective of our assignment, our DSP assignment, which is first, learning and understanding more about FIR filter and its application. Okay, next we have to develop best method of FIR filter design, and next we had to analyze filter performance to get the desired output of FIR filter design. After that, we had to utilize the FIR filter design and application using the MATLAB software. And furthermore, we had to synthesize the best filter using proper structure and proper implementation form.
Today, I would like to present about the methodology. The purpose of doing the finite impulse response filter because it has the frequency response of the filter durations, meaning that it's settled to zero in the finite time. Besides, it's easy to implement and enable the system to become the stable when we are designing the FIR filter. It also helps the student to learn the DSP and carry out the project in the stage through the graduate steps in subject related with the digital signal processing, which can be found usually in industrial such as the digital filter, ad hoc canceller, audio equalizer, modem, voice processing algorithm, imaging. This project needs students to demonstrate a digital processing technique in digital signal processing applications and needs them to be filter the signal using the filter response. Then, we have to use the signal given to obtain the graph from the MATLAB and also decide on the type of the filter has been produced. By using the MATLAB, it improves our knowledge on how to produce the code and also the graph and the type of the graph being produced. This is a workflow. As long as you can see, first we need to understand the applications of the finite impulse response filter, then distribute the task among each group member. Then all of us need to do some research about the MATLAB language for finite impulse response filter. Then we can begin with construct and estimate the spectrum based on the applications of the finite impulse response filter by using MATLAB software. During we do the MATLAB simulations, we need to check for the debugging for the codes and also estimate output spectrum based on the finite signal that we use or that we produce and verify the error. Lastly, we publish and compile all the reports. The next is the strategy and approach design. In this project, the analysis of any sample signal or sample data system in the frequency domain is extremely difficult using the Laplace transform because the signal or the system equations will contain infinite long polynomial down to the characteristic infinite number of the pole and zero. So we will use the Z transform technique in order to reduce the pole and zero to finite number in the Z planes. Besides, there are several common windows that use the finite impulse response filter. In this project, we apply a window-based technique design using the impulse response of ideal filter. By using the window technique, a multi-purpose FIR filter is designed. It is the most suitable algorithm because it is an easy way of a FIR filter realization. By defining the piecewise function with the discontinuity at the boundary between bands, the frequency response can be achieved. By using the predefined windows, the specifications of the filter can be easily found, which means it will match the filter applications or match the filter specifications. Then, the coefficients can be calculated by mathematical models. The window selection is based on the stability and causality of all types of filters such as a high-pass filter, low-pass filter, band-stop filter, and also the band-pass filter for a windowing algorithm. The specifications which can be considered for the window are the transition widths, peak stop bands, attenuations, and peak side lobe amplitude. The trade-off between the transition with the peak stop bands attenuation remains. Transitions will get the biggest as soon as the window get higher stop band attenuations. Software. In order to done with the part of the simulations, we are try using the MATLABs, which abbreviations called the Matrix Laboratory. Is a high-performance language for technical computing. It integrates computations, visualizations, and programming in easy-to-use environments, where problem solutions are expressed in familiar mathematical notations. Its typical use include math and computations, algorithm developments, modeling, simulations, and prototyping, data analysis, explorations, and visualizations. And last but not least is a scientific and engineering graphic.
In this section, I will explain about the coding and how to simulate the MATLAB code in the MATLAB software. Okay, so this is our coding for window function method of FIR filter. Okay, and this first part is we had to use the 100 and 200 hertz frequency to produce the input signal. Okay, and we use the Hamming filter window, which is this, and FIR filter in order to filter out the input signal, input signal that contain a noise, which is this. Okay, in this section of this coding, it will create a graph of sine wave with a noise of superposition, which contain a superposition noise with two frequency spectra, which is the 100 and 200 hertz. And after that, this is the last coding, which show the output of the signal after entering the FIR filter, and it will smooth out the signal and remove the unwanted of frequency. Okay, and then after we had code, after we enter all the coding in this script window, we press the run, we execute the simulation. Okay, and then it will show a three figure, which is in the figure 1, it show the gain response of low pass filter. Else you can see after the 100 After it reach to 100, it will start to fall down into the constant into a constant wave until it reach to 1000 hertz. And next, and this is for the figure 2. For the figure 2 of the result MATLAB, which show the input signal which contain a superposition signal, which is this, that contain the noise, and it's also in the frequency domain. It also contain the 100 and 200 hertz of frequency. Okay, after that, in the figure 3, it will show the input signal after it has been filtered by the FIR filter, and it will smooth the sine wave waveform in the time domain, and in the frequency domain, it will remove the 200 of the frequency and only shown the 100 hertz only, part of the signal only. Okay, as you can see, based on the output that we get in the input signal, they are noise signal with two position signal that contain two different frequency, which is the 100 hertz and 200 hertz in the frequency domain of the input signal. Okay, so we had to require to filter the input signal by using the Hamming window function with the sampling frequency of 2000 hertz. So by comparing the input and output signal, it can be seen that there are two frequencies that needs to be filtered. The signal with frequency of 100 Hz, which is in the range of passband, is kept, while the signal with the frequency of 200 Hz, which is in the range of stopband, is filtered. The minimum stopband attenuation value for Hamming window are 53 dB, which is greater than 50 dB that enable us to get the filter waveform with 100 Hz only. Besides that, on figure 4, it can be shown the response of FIR filter, low pass filter gain with the 100 Hz signal that was filtered to remove the other frequency in the signal. Okay, that's all for me. Thank you.
In conclusion, we will select a finite impulse response filter as our main topic in this assignment. Besides, the student can learn and acquire a better understanding regarding about FIR filter and its applications. From the other point of view, the students should be able to design a finite impulse response filter to simulate the coding by using the MATLAB software. In addition, we need to analyze and synthesize the filter performance by using a proper structure and implementation form to obtain the desired output for FIR filter design. Finally, we were able to identify the type of the filter used and demonstrate how the simulations in the MATLAB software.